Back to my YouTube channel. Today we'll be dealing with shear modulus. We're still under strength of material N5. We have given there. We have a summary, little summary. Sorry about that. Yeah, little summary there. We have the shear modulus is the illustrative modular we use for deformation change in shape. Okay, take place when a force acts on an object parallel to one of its face while the opposite face held flexed by another equal force. A good example is placing a force top of the thick book that rests on the surface. When a book is like a block height, okay, we have given this. This will be better if you can check that book. Here is the book. You see, if you try and you share, this is the share, you move your hands forward to apply the force, you see your book will slant this side and also will slant, will slant like this. You see, you must ask yourself why, what caused it to be like that. So yeah, so that is a share we're talking about. We have that share, the shear strain as defined as shear strain. We have shear strain, or the shear strain is gamma change in x over the length, but we're talking the length is the one, the height, not this one. No, but the length, we consider the height, call it the length. Change in length will be this one. There, as you can see, that will be x, will be the change in length. That's how we consider it, will be x there, our change in length. So yeah, so that is what we have. So this y is called what? Modulus of graduality, or modulus of graduality. It's a value that tell us the relationship between the shear stress and the shear strain. As you can see, is what we have given them. So when considering the shear stress and the shear strain during the elastic stage, the relationship between the two is unknown, is known as a modulus of rigidity, which is G. Note you've given here, they said note this value of G is very important later in the syllabus when you have to calculate the twist of the shaft or a toe. Okay, yes, you will see this. The torsion that module is on, will delete later on. I will do it and then my video will be posted. Will deal with this topic. You'll see it when you're talking about torsions, all those stuff, right? No problem. So as you have seen, as you have heard, so how to, the formula for calculating modulus of rigidity. We know that modulus of rigidity, we have the constant modulus of rigidity G. So now we have modulus of rigidity, which is that shear stress over gamma. That gamma there is, we call it that gamma. It's one that we have called it here, which is the shear strain. Our shear strain now is represented by gamma. Remember, firstly, our shear strain is like this, the original one. Now we have gamma. So here it's a shear strain, shed, the shear. Now we have a gamma there. So shear strain, talking about shear strain, here we have strain. This is a gamma, we shear strain. Talking about shear strain, this is a shear stress. This is a shear strain. Now it's a shear strain. Then it's a shear stress. So the relationship between the two, you must note gamma there. This is what we have now. We know that the shear stress over the shear strain now will give us gamma. The shear stress over the shear strain will give us gamma, will give us modulus of, will give us the modulus of rigidity. Remember, first E, modulus of elasticity. Remember, what was the modulus of elasticity? It was stress over what? The strain. But now we have modulus of rigidity, which is the shear strain. Remember, now it's a shear. Then this will be over gamma, which is your shear strain. These are shear. We're talking shear stress, shear strain. We're talking about this. This is simply just a strain, straight direct strain. Those are shear. So yeah, this is what we have. As you can see, we'll consider the length as the height, then changing length will be that distance there. Okay, it's fine. And nevertheless, so here this is modulus of rigidity is usually in gigapascal. We know that blah, blah. Y is a shear strain is often given in radians. Take note of that, but still a ratio is still a ratio also. So we use the apparatus in the figure. Where is the figure? Where is the figure? Where is the figure? Oh, where is the figure? Okay, it's fine. I forgot to put on the figure here, but the figure is something like this. I will given something like this. If I construct that with something like this, something of this nature, we'll have something like a plate like that, right? Something like this, the figure there, and then you'll have there you'll have your cylinder in that manner. Then yeah, you'll have something like of this nature. We'll have something of this nature. But I won't see that part. Yeah, something like that. Then we also have, we will understand. That is it. So yeah. So here it has some clips there. It has some sort of like this thing, and then this thing is 100 Newton. Then this distance here, we have given it to be 25 millimeter. Then this distance of this box there will simply equals to 300 millimeter, be 300 millimeter. Then this one like that simply equals to 100 millimeter. Then we are given something like this of this nature. We have seen when we apply that, then we'll have this thing of this nature. So here we'll have the hidden detail, as you can see. Then you'll have that. So this distance here within the hidden detail will be 1.2 millimeter. This distance there. Then here shows in what this force, there's area 100 Newton like that. Then this distance to there is 100 millimeter. So yeah, this is what we have in all. So the figure shows this. It says in figure apparatus 1.13, which is that I've drawn, to determine the shear modulus of the rubber. When the shear load we've given, the deflection is that, calculate the shear of modulus on the rubber. Okay, it's fine. We want to calculate that. We want to calculate G, which is shear stress over shear strain. Okay. So but shear strain alone is equal to force over area, and also gamma by alone shear strain alone is equal to that. So we have to find these things first in all for us to get there. If we can get this, we'll be fine. So it's up to you. I can start by force, or I can start by area, or what. The force we are given, let me not start by it. We are given, let me just calculate the area there to make my life. So area, focusing on the area there, the area of this box, because the one that we are checking, and there we have 300 millimeter into 25, whereby this is simply equals to 0,3 times 0,2 0,25. This area will be equals to 7,5 times 10 to the power of minus 3 squared. We have the area. Now since we have the area, we can find the shear stress there, the direct one. You can find it. We know the force you've been given, which it was 100 is the 100 Newton, divided by so much by this area, then shear strain will simply equals to 13,333 kilopascal is measured in pascal. Remember, we are done with this. Now we're left with, if we can find the shear strain. We have the shear stress. Now the shear strain, we want a change in length. Okay, we have that from this. Remember, the change in length will be this one. I've made the example about the book. I said the change in length will be that. I made the example here. Here's the change in length. We have this structure. Then I said the height, this height, we'll call it this height, will be the same as the original length. So we have, remember, if we take it, we will place it like this. When we make, you see how do they put that, the difference is like this. You see the difference, they've just laid here. We have it, that distance here, either way, no problem. The now what do we have? The x is, it's 1.2 millimeter divided by 1000. This is supposed to give you 0,0012 over 0,1, which is 100. That will be 0,012. Remember, it's a strain, it has no SI units. Then our modulus of rigidity we have will be 13,33 multiplied by 10 power of 3. Here's kilopascal there, all over 0,012. It's up to you. Then when I punch this, I will make it to be in megapascal. This is what we'll have, and that is what we have there. So either way, yeah, you'll have a bit now. Yeah, that is what you'll have there. So thank you guys for watching. This is what is it. Please do not forget to subscribe then. Subscribe. As you can see, if you face down there, you'll see a yellow I've written subscribe there on the bottom of my video. Please do so to go to my YouTube channel and subscribe and click that notification button, so that you'll be notified whenever I post a new video. Stay tuned. All the best.